Hello friends, let us consider very important concept related with electrostatics, and that is types of electric charges. We know that electric charge, it is always produced by means of transfer of electrons. Means when any body it is rub on another body, there is a transfer of electron or gain of electron. When body loses electron, then that body is said to be acquiring positive charge, and when body gain the electron, it acquires negative charge. And we know that charge acquired, it is always given by formula Q is equal to plus or minus Ne. This is the law of quantization of charge. Total charge on any body is always quantized, means it is in the form of integral multiple of electronic charge. Here E is always 1.6 into 10 raised to minus 19 coulomb. Now here N is nothing but number of electron, yes, lost or gained by body. Plus sign to be used when body loses electron, negative sign when body gain electron. So this formula already we discussed. Now we are going to consider the type of charges. Now the charge, whatever charge is developed, it remains at a single point. You just imagine this is a tip of a glass rod, and if it is rubbed on certain material, for example silk, and whatever charge is developed, as it is a glass material, it do not pass through that material. It remains at there. It remains there only at that tip, at that point, and hence it is called as a point charge. Means point charge is nothing but such a charge, yes, which deposited at the pointed portion of a body. Means if we consider, yes, such kind of, yes, pointed portion of a body. Suppose this is a rod under consideration, and if it is rubbed on certain material, then whatever charge is developed, if it is insulator, maybe glass, ebonite, amber, plastic, mica, whatever it may be, then whatever charge is developed, it remains there only at that point. Such a charge is called as a point charge. It will not spread anywhere on this body, except that point it is not present anywhere. It remains at that point, and hence it is called as a point charge. Now second type, we know that charge is expressed always in SI unit coulomb. You must know it. If smaller charge is there, we are using millicoulomb, microcoulomb, nanocoulomb, picocoulomb, and larger charge kilocoulomb, megacoulomb, etc. etc. But generally large value is not in our syllabus. Generally smaller units will be required, such as a millicoulomb, microcoulomb, nanocoulomb, picocoulomb, etc. And conversion factor must be known to you. Now second type of charge is called as a linear charge. What do you mean by linear charge? Instead of considering a plastic body, if we consider a metallic body, suppose this is a metal plate under consideration. You just imagine this is a metal plate under consideration. If it is rub on certain material, you tell me what happened? If it rub on certain material, either it lost the electron or gain the electron. If it loses electron, guaranteed it will acquire certain charge. Suppose this end is rub, then whatever charge is produced, it do not remain at that point. It will spread everywhere on its total length. It will spread everywhere on its total length. And such kind of distribution of charge, or such type of charge is called as a linear charge, and the distribution is called as a linear charge distribution. Linear charge distribution. This is very, very important. Now if L be the length of this body, capital L, if we take symbol for length of body, if total charge on this body is Q, then how much charge is present on 1 meter length? Unit length वर किती चार्ज असेल ते सांगण्यासाठी इथे आपण क्वांटिटी लिहिणार आहे, linear charge density. Linear charge density, generally symbol used, it is lambda, and no doubt it is defined as the charge per unit length. Means total charge on body divided by total length is called as a linear charge density. Linear charge density, yes, and no doubt it is denoted with symbol lambda given by formula Q by L. SI unit is coulomb per meter. No doubt it is scalar because charge is scalar, this distance is scalar, so scalar divided by scalar ratio will be scalar. So linear charge density, it is a scalar quantity, and it helps us to get charge on a desired length. For example, for a given body, if we say lambda is given as a 2 coulomb per meter, what it implies? 2 coulomb is the charge on 1 meter. If I say length of this body is 5 meter, now what will be total charge? Simply you have to multiply lambda by that length. So if I multiply lambda by length, I will get charge on that much length. Means 5 meter means 5 into 2. So 10 coulomb will be charged on entire length. This is the advantageous point of this quantity called as linear charge density. Sometime in your computer examination, there may be question to deduce dimensions. So dimensions of lambda will be dimensions of charge divided by dimensions of length. So using this formula, you will get dimensions. Now third type of charge is nothing but surface charge, or distribution of charge is called as surface charge distribution. Means instead of considering a given metallic body linear, if we consider in the form of, yes, a hollow conductor having certain area, for example metal plate, or we may consider as a hollow metallic sphere. You just imagine this is a hollow sphere under consideration of metal only. Yeah? Now whatever charge is developed, now it do not focus at a single point or concentrate at a single point. It will spread everywhere on its entire surface area. Means if charge produced on a body or given to a body, if it spread everywhere on its total area, then it is called as a surface charge distribution. Surface charge distribution. If Q be the total charge, then how much charge is present on 1 meter square area? On that unit quantity, how much charge is there? In order to get idea about it, a quantity is defined here called as a surface charge density. Surface charge density. Symbol taken, it is sigma, and is defined as like lambda. Here sigma is defined as charge per unit surface area. SI unit is coulomb per meter square. Very important. It gives us idea about how much charge is present on 1 meter square area. Now here sigma is charge upon area. If it is a, yes, hollow sphere, area we know the formula 4 pi r square for spherical conductor. Instead of, yes, such kind of spherical conductor, if there is a hollow cylindrical conductor, if there is a cylindrical conductor of length L and radius of cross section R, then what will be area? Area will be 2 pi r L. So here entire charge will spread everywhere on this total surface. Only at the periphery. Middle portion is hollow. If hollow charge is there, there is no charge inside. Always remember, for all hollow conductor, charges are present on their outer surface only. Inner surface no charge. Inside charge is always zero for hollow conductor. This is very important point to be noted. Now the third type is called as a volume charge. What do you mean by volume charge? If total charge given to body, if it is spread in entire volume. Now generally this term is required in case of, yes, solid geometries. Imagine this is a solid sphere. It is a solid sphere. If it is a solid sphere, it has a volume, yes, 4 by 3 pi r cube. And if it is charged now, where that charge will spread or where it will be deposited? Not at the center, not on the surface. It will spread everywhere in this total volume. It will spread everywhere in this total volume. Then it is called as the volume charge distribution. If total charge given to body spread everywhere in the total volume, it is called as a volume charge distribution. And how much charge is present on unit volume? It is given by a scalar quantity called as volume charge density. So what is formula? Volume charge density, it is denoted with symbol, yes, rho. Sigma for surface charge density, like charge per unit volume. This is definition for volume charge density. Very, very important. Volume charge density denoted with symbol rho is defined as charge per unit volume. So SI unit comes out as a coulomb per meter cube. Now see here, if solid sphere is there, volume 4 by 3 pi r cube. Like that, if cylinder is there, you just imagine this is a solid cylinder, and if total charge spread everywhere in this total volume, then volume of cylinder, what is formula? Pi r square into L. This is the formula to be used for volume of this solid cylinder. So this is in brief idea about the distribution of charges or types of charges. First one is the point charge, second one linear charge, surface charge and volume charge. And we know that Coulomb's law is applicable, strictly speaking, only for point charges. And for the surface linear charge, surface charge, volume charge, to find electric intensity, Coulomb's law is not applicable. And that's why we have to discuss about one of the important, yes, law, just to overcome the limitation of Coulomb's law, and is nothing but Gauss law, or also called as a Gauss theorem. And in order to understand Gauss law or Gauss theorem, we needs one of the important physical term, that is electric flux. And that electric flux, there is symbol, formula, SI unit, everything. Detailed idea about that electric flux we will take in next video. Okay, thank you very much.